find the coordinates of vector x relative to basis b given the following. So to get us started here, we want to recall how our coordinate vector of x relative to b is defined. And we recall that it is defined as the vector of coefficients, or the vector of the weights of our vector equation. So we know that these coordinates, they must satisfy the following vector equation. So they must satisfy the vector equation defined by vector x is equal to c sub 1 times vector b sub 1 plus c sub 2 times vector b sub 2. So let's go ahead and plug what's given in. So we know what we're looking for. Again, we want to find c sub 1 and c sub 2. So let's think about this. We have c sub 1 multiplied by vector b sub 1, which is given to us as 4, 2, plus c sub 2 multiplied by column vector b sub 2, which is given to us here as negative 2, 2. And this should be equal to our vector x, which is given to us here as 8, 10. So we know that this vector equation is equivalent to the matrix equation defined by the column vectors 4, 2, negative 2, 2, multiplied by the column vector c sub 1, c sub 2, and that's still equal to vector x, which is 8, 10. So now to find these coordinates c sub 1 and c sub 2, we can row reduce the augmented matrix, where the column vectors are defined as b sub 1, b sub 2, so there's our matrix A, and we're augmenting this with vector x. We want to row reduce this to row reduced echelon form to find the coordinates of vector x relative to b. So here we go. We have 4, 2, negative 2, 2, and we're augmenting this with 8, 10. And we think, hey, we can simplify this. We could do 1/2 times the first row and 1/2 times the second row to get the equivalent matrix. 2, negative 1, 4, and then 1, 1, 5. And for simplicity here, I'm going to interchange the first and second rows. And so this is equivalent to the matrix 1, 1, 5, the augmented matrix, 2, negative 1, 4. And looking at our first pivot position here, we see that if we multiply the first row by negative 2 and we add it to the second row, we can produce the new second row. So this gives us the equivalent matrix 1, 1, 5. And then we have negative 2 plus 2 is 0. Negative 2 minus 1 is minus 3. And then negative 2 times 5 is negative 10. Plus 4 leaves us with negative 6. And we can simplify that second row here. We could multiply our second row by a scalar of 1/3, negative 1/3, which leaves us with the augmented matrix 1, 1, 5, 0, 1, 2. And we're almost there. So last but not least, again, looking at our second pivot position here, we can use this to eliminate the entry above by doing minus the second row plus the first row to attain that new first row. So we have 1, 0, and then we have negative 2 plus 5 is 3, and the second row remains as it is, 0, 1, 1, 2. So we have solved our system here, and this is equivalent to saying that c sub 1 is 3 and c sub 2 is 2. So therefore, the coordinates of vector x relative to our basis b is the vector 3, 2. And this is our beautiful final answer.